Well, hello everyone. Thank you for coming. As Nicola mentioned, I'm Matej Konecny. My title at Atlassian is Senior Developer. I'm working with Atlassian for, I think, a little bit over 4 years. And, well, my story of building JIRA server add-ons microservice actually started, I think, almost 4 years ago. And it started as a story of JIRA automation plugin, which some of you might not know. I built this add-on with Atlassian Connect, who might be somewhere in the audience, maybe not. And it's a P2 add-on, which actually allowed us to do a lot of automated stuff in JIRA. So we used it in the past to configure JIRA to do certain actions based on events happening in JIRA. So for example, when a user created an issue, we could add an automated comment to it. And that was very powerful at that time. It was, I think, JIRA 5.2 was released, and we used a lot of direct Java APIs to access functionalities we need to do. And that gave us a lot of dev speed, a lot of power to do things that were maybe more difficult to do from other tools. But then JIRA 6 came out, and that actually meant an upgrade and some rework. I think JIRA 6 brought user keys instead of usernames, and we needed to go and refactor some of the parts of the add-on. And same thing happened with JIRA 6.1, and I think within the last major release with JIRA 7, this is how our Bamboo pipeline looked like. Maybe you know it. There is a new version. Things change. So every major upgrade kind of broke things for us. And last year, I was approached to do something similar, and I thought, well, there must be a better way to do this. You're not going to use a hammer to use for screws, like in this picture. So I thought, well, we can already identify the problems that I was facing with, and it was in the P2 add-ons, you share the same resources with the JVM, so you're kind of limited with the application server. You also use mainly Java APIs, and I love Java, don't get me wrong. It's a great language, but sometimes you want to use something that's maybe more suitable to parse JSON or to work in, in a multi-thread environment. So you don't have to be limited here. And the last thing was it runs within JIRA, which is good because you don't have to take care of the platform. But also, when JIRA is down, your plugin just doesn't even exist. And on the other hand, if we externalize things in a specific service, what you get is you're not constrained by the resources. You can basically scale the way you need to scale. You can be technology agnostic, so if you need to use Closure or Node, you can just use it. And run everywhere is something that became more important to my team in the last years, because we wanted to run in AWS, and that's what we can do now with the microservices. So to externalize all the things, this already happened for Atlassian Cloud. So Atlassian Cloud already has Atlassian Connect, which you can use to trigger your code based on events in JIRA. So let's say issues created in JIRA, and Atlassian Connect makes sure that your code is being triggered where it's running, and it runs somewhere on your own hardware. And then I thought, well, why don't we do the same in server? Server has webhooks, and it's, in my opinion, a little bit underutilized feature in server because it's so easy to create a P2 add-on that just does it. But if we use webhooks, you can trigger them globally or from a workflow, but your code doesn't necessarily live in JIRA. It just is somewhere, and JIRA makes sure it's triggered. And to talk back to JIRA, instead of using Java calls, you can use REST. You can do JIRA issue updates, adding comments, creating users, whatever your application needs to do. And the great advantage here, instead of using P2 APIs, is that you are using versioned API, which is, in the last years, I think very stable. They're adding new features there, but the old features still stay the same. And the same API works in cloud. And last thing that I wanted to do in my case was storing some data in JIRA issue view. So I used to use custom fields to do that. Just very simple. You store that value in custom field. JIRA makes sure it's rendered, and that works. If you need something more complex, I guess there are different ways to achieve that, and I'm going to go very briefly about it later, because this requires a little bit more work to embed an iframe from your service, external service, in JIRA. But it's doable. It's just something that you kind of need to weigh in if it makes sense in your case. But biggest change to actually achieve this kind of architecture versus P2 plugin, in my mind, was like the mindset. So instead of building a plugin, we are building a service. So the service is something that actually should live a little bit agnostically to what you're doing. You're trying to solve some problem for your customer or for a group of customers. And I was thinking of a good example here. So, for example, imagine that you need to add some information to JIRA issue. And you just fetch it from external service, you add it as a comment. That works great. And then you switch to Trello, because why not? And after that, you kind of have like plugin that lives in JIRA in P2 world. You still need to fetch the data, and you can attach to the Trello card as a comment, but you will have to rebuild the whole plugin as a service that runs somewhere else. Well, if you think about it more agnostically, there is just a service that performs certain business interaction, in this case, fetching the data and adding it somewhere. And if you use a microservice, you probably need to just change a little bit of the REST call. Instead of JIRA, you'll be calling Trello. But hopefully, you can reuse it. And that's not where the reuse ends. I think 90 to even 95% of the code that you write as a microservice, you can reuse in Atlassian Connect. And that's huge. I think everybody who's working and creating plugins for both cloud and server can relate to this, that it's something that you would really like to have. And I'm going to show you how to do something like this in an example. So in the next couple of slides, I'm going to take you in building a microservice that fetches data from Salesforce and then attaches some of the data to JIRA issue. So just a quick show of hands, how many of you know Salesforce or is using Salesforce? Okay, that's pretty good. Something like maybe 30, 40%. That's more than expected. For those of you who don't know it, Salesforce is a world-class CRM, customer relationship management system, that lots and lots of sales teams across the world use. And I think it's for them, it's like JIRA is for us. In Salesforce, you can store information about an account, members of a customer account, like contacts, what kind of interactions that you had with them, if they were part of marketing campaigns. And in our case, in Atlassian, we also use it. We use it to manage information about our partners and our customers. So if there's a certain bigger customer that we interact more often with, each of these customers has a dedicated account owner, we call them, someone who within Atlassian knows what kind of problems do they have, what kind of installations do they have, things like that. So whenever someone from our support team received a support case, they basically needed to know, this is a big customer. Who should I be in touch with within Atlassian to let them know this customer is having issues? So we thought, well, we can add one small custom field, account owner, and we'll pull the information from Salesforce. And the way to identify that is pretty crude, but it works. We basically look at the report of the issue and look at their email address. Everything that's part of the domain, that's something that we match in Salesforce to an account. So each of the accounts that we have in Salesforce has a domain associated with it. So whenever someone, let's say from Atlassian.com would raise an issue, we see, oh, the account owner for this domain is this person. And we just show it here. This actually saves quite a lot of time to our support engineers and our customer advocates who were doing this manually maybe 5 to 10 times a day. And it's a small thing that we're going to build in the next 20 minutes. So now that we know what to build, let's look how to build this. And when I approach a bigger problem, I try to break it into smaller pieces. So that's what I did here. I took a look what we need to achieve. There's an issue that's going to be created. We need to fetch data from Salesforce, and we need to update the issue. Took a sheet of paper, and I drew it as a kind of a flow chart. As you can see on the left, issue comes in, issue is created. Then we make a call to Salesforce. Then we parse the data, figure out who is the account owner, and we just update the issue with that information. Pretty simple, right? Now, if you just take a look at this gray box, this is actually something that your application is doing. This is your business logic. So everything after issue created, it's something that we can either do as part of P2 plugin or as a microservice. And in truly microservice architecture, this should be just the one thing your service does, as some people say. So microservices architecture essentially equals to the Unix philosophy of doing one thing, doing it well. So you do not try to cram multiple things in there. I suggest if you go this path, go and figure out what's the core of the service of the application that you're trying to build and get that in. This new approach requires a little bit of new tools. As I mentioned, we'll be using webhooks instead of Java listeners. So whenever an issue is created in JIRA, we'll be having a webhook, and that webhook will be triggered. We'll be using REST calls, as I've mentioned, instead of direct Java calls. There are some nuances to that. I'm going to go through to that a bit further. And we'll be storing some data in custom fields instead of building panels, as that's a little bit easier to do in 20 minutes. Let's start building, and I'm going to use Node to do that. So I kind of try to break it down into 4 pieces. And the first one is just building a skeleton app in Node, listening on port 3000, and actually just going and making an authenticated call to Salesforce eventually. So let's start here. As you can see, I have here an app that just listens on port 3000 and just prints hello world. It's nothing very spectacular about it, just a proof of concept that we have set everything correctly. Refresh the browser, and you can see it shows hello world. That's great, but it's not what we wanted. So I'm going to add auth2 library because Salesforce REST interface requires auth2 authentication. I've set this up already, so we already have the client ID secret and the refresh key. But yeah, in your case, depending on the application you're using, it might be something different. So once we have that, we're just going to configure the library that's in this block. And as you can see, there are a bunch of things that I'm setting it to. But the most important things are the client ID and the secret, which I'm actually storing in environment variables. And the reason to do this is, well, you obviously don't want to have it in source code, because if that happens, somebody reads your secrets, they're compromised, and they can use them to do malicious things. So there's a great bunch of principles. There are 12-factor apps written by Heroku. And I'm trying to externalize the configuration into somewhere external, in this case, environment variables. So once we have the client configured, I'm going to use the client just to get refreshed auth2 token. And again, this is just basically using the library as a document on GitHub. I'm taking a callback function as a parameter. So once I get the refresh token, I'm going to call the callback function. It's a JavaScripty way of chaining calls. I didn't want to use anything like promises here, just keep it simple. And the application is just changed slightly. So when we receive the refresh token, I'm just going to send it back to the client just to refresh it. So just to display it. So when we refresh, the Salesforce token is there, which is great. It's valid for, I think, 4 hours. No harm in seeing it right now. This is great. But we wanted to see who is the owner in Salesforce. So let's take a look at how it looks in Salesforce. This is something that a lot of salespeople can relate to. It's an account view of Atlassian Test Partner account that they've created. And there's like lots and lots of custom fields that you can add. My main focus is on 2 fields, and I'm going to highlight them. So as I mentioned, we have the domain field. In this case, it's Atlassian.com. And this is the field that identifies, our world, who is this account related to. And the second field that we use is the account owner, which is somebody from Atlassian managing all communications with this customer. So now I'm changing the code a bit. What I did, I checked the new version, and the new version is making a REST call to Apex REST domain info. You can see it on line 42. And it's actually sending, give me information about the domain Atlassian.com, which is part of the query string here. And I need to pass the access token there, because that's how auth works. And once we get this back, we get JSON back. You can also configure to get XML. I like JSON. So once we get it back, well, I'm going to just parse it. And this is the beauty of Node, because it's JavaScript, so you don't have to use Jackson or anything to parse JSON. Just display it. I'm going to navigate to owner, and I'm just going to display the owner's name on a web page. So now when I refresh this, I'm probably going to end up at a breakpoint. That's correct. And the domain name is, the domain owner is me, which you have seen before. It's nothing surprising, but the effect of this is that we now have a small application that actually displays who is the owner of Atlassian.com domain in Salesforce. So this is something that is almost ready to react to JIRA events. We have things hard-coded, but we only need to get that one string that is the actual domain, and we can actually figure out who the account owner is for any issue. So this is just a refresher. Webhooks, if you have never used them, they're available server, and they can be triggered by almost everything in JIRA. It can be issue created, comment edit, work log edit, even project and user edit events. They can be global events, or it can even be part of a workflow post function. So you have a lot of flexibility in configuring. It's something that you need to do manually. In cloud, this happens using your Atlassian Connect descriptor. But this is not something that's too difficult to do. You just need to do it once. The way webhooks work is JIRA tries to send HTTP post to predefined URL that you configure as seen on the screenshot. Once that call is made, JIRA waits, I think there's a 30-second timeout, and it expects something around 200 from your microservice or from your endpoint. If that doesn't happen, it tries 2 more times, and after 3 retries, it logs an error in error log. So that's good to know. It's not never-ending trying to hit it. You have 3 times, and then there is an error logged. Another part of the code is actually showing you how to do this. So first, I'm going to just display what kind of JSON do you get back from JIRA. And later, we're going to use that JSON to extract the information that we need. So I'm configuring some body parser needed for Express to actually parse the body. And I've replaced my endpoint to be actually looking for HTTP post to /create endpoint. And for now, I'm just going to log the JSON that we get in the request body. To configure JIRA, we just need to do GG webhooks, create a webhook, give it some descriptive name, and excuse me, set the endpoint, which in our case is localhost 3000/create. You can even include some of the variables shown in the help text. I'm not doing it here. You can also specify a JQL, and the way this works is JIRA first tries to look if the issue created, for example, matches the JQL that you've specified, and if it does, then it calls your endpoint. If it doesn't, nothing happens. This only works for JIRA-related events. These are the issues, these are the events that I was talking about. So you can see there is work log, there's comment, there's issue, there's project-related events, user-related events, even JIRA configuration-related events. And there's a flag. If you do not care about the body, about the issue itself, you just want to know something happened in JIRA, you can exclude the body. That's not our case, but it's there to save a little bit of bandwidth. Now we hit create. This is just the configuration of webhook, so nothing actually got triggered in JIRA. It's just the configuration was created. Once we create an issue now, we're just going to hit the webhook. Great. So I had a logger here. And if you look here, there is a whole blob of text. This is what JSON representation of JIRA issue looks like. And you can even, like, if there are multiple comments added, for example, you will see them here. So there's a lot of information in here. And this is all documented on our documentation. So there's nothing, there's a lot of you can do with this already. Next thing is, we're going to parse the data. So instead of hard coding the Atlassian.com domain, we are going to look who's the reporter of the issue. And that's that simple. I'm just going to look in the body of the request. I'm going to extract in the fields, there's going to be a reporter field, and I'm going to take their email address. And everything in this email address should be hopefully just one @sign, and everything after that @sign is a domain. If it's not, we just send 400 back. This is a bad request. I mean, not much we can do with it. This gives us the domain. So let's use this domain in our REST call to Salesforce. So I'm logging it here, and I'm also using it instead of the hard-coded Atlassian.com. Luckily, I've set my reporter user in JIRA to also come from Atlassian.com domain, so we should be getting the same response as we have had before. But now it's not hard-coded. It's actually reading it from the JSON that we have received. I'm just going to print it to console right now once we get the response back from Salesforce, just step by step. Couple of breakpoints, and create an issue in JIRA. I'm using my reporter as the admin user, and the admin has email set to be admin@atlassian.com. So that's going to be, you can see it here on line 32. You see that the report is actually admin@atlassian.com. The domain is properly expanded. It's atlassian.com. It's going to make a call to Salesforce once we get it back. Yep. Once we get it back, yep. We see that there is some JSON coming back, and it's the same JSON. I'm again the account owner of this domain, but now it's all based on the information that you get from JIRA. So that's great. This brings us to this. So we have JIRA sending a webhook to a microservice. And microservice does some logic, fetches the data. To talk back to JIRA, we'll be using REST. And to talk back, it's a little bit different than just using standard Java interface. So to do REST right, first of all, you need to have a user. So this user needs to have an access to the issue or to the project that you're trying to modify. So my suggestion is create a dedicated user, manually or make it automated process, but just have a dedicated user that's going to be doing these updates. Make sure this user has the right permissions to do the updates or the changes that you need to make. Second part is you need to authenticate. In our case, we'll be using basic auth because it's much simpler to set up, but JIRA supports auth. You'll be basically doing a REST call, and JIRA needs to know who you are and that you are actually the right person. So that's why it needs passwords. If you need to store secrets, just store them securely, hash them, solve them, or store them in environment variables, as I've shown. And the last part is that's something that you do not have to deal that much in P2. You just need to handle errors, and in specifically connection errors, because I mean they will happen. Like there's going to be a situation where you make a call to JIRA and it's not available because it's, I don't know, it's upgraded or something. You want to make sure that your microservice can handle that properly. Simple JIRA issue update can look something like this. So on the left part, you see you make a call to Salesforce, you process the data, and then you create some JSON shown as an example on the right side, and make an HTTP put back to JIRA. So this JSON just shows, I'm going to set custom field 10,000 value to Fred, and I'm going to get just one label. You can do multiple things there. You can add entity properties, can change SNEs. It's just basically one blob that you send to JIRA. And again, this is very well documented in developers at Atlassian.com. The endpoint that we'll be sending this HTTP put to is actually provided by JIRA itself in the webhook, not in the webhook itself, but in the body of the request. So it's a special field that's called issue self, and that's an endpoint that uniquely identifies the issue within that instance, and you can just make HTTP put on that, and JIRA will know, I need to update this issue with these values. Part of the code here is, well, we need to configure custom field. I'm going to use a single line custom field called account owner. Once that's created, this part is, normally you don't care that much about this, but for REST interface, you can only update values using REST interface if they are part of the edit screen. So you need to make it part of the edit screen to be able to update them. That's something that took me a while to debug, so I wanted to stress that if you are sending the right JSON, try it in Postman, and make sure that you can just do the REST call yourself. And if you cannot, then probably this is where you are having an issue. So now this field is in that project. It's added, and as I mentioned, we'll be making the callback to JIRA. So I'm extracting the issue self here, again from the request sent by JIRA. It's part of the issue object, and it's the self property. I'm just going to log it, but yeah, it's part of the JSON, so you can explore that. And what I'm doing here is, once I get the data from Salesforce, I'm going to parse the owner name, and I'm going to create that JSON to send as HTTP put to JIRA. And you can see already there's a section auth. So this is the way how it's done in Node in the request library. So I'm going to pass a user and a password. Again, read from the environment variables. It's going to be put method, and the actual body of the request is for now just containing one element, it's fields. And I'm again going to set the field that I wanted to set to owner name. It's very simple, just going to create one element in there, and JIRA will know I need to update this field. And I'm just going to fire the request. Once it's done, I expect that JIRA will respond with something like 200, 204, something like that. Creating an issue is then pretty simple. I've already set up the environment variables for the user to be my admin user. It's not something that I've recommended to you, and I will show you why it's not recommended. Because right now, I'm going to hit create. In my code, I'm going to go fire the call to JIRA. And once it's done, it's going to return 204. Yes, which is great. And right now, we have the account owner here. It took us something like 15 minutes to have this. We didn't use any part of Atlassian plugin SDK. This is pure Node application. It works. Great. And the author of this change, if you look at the change log, is the actual user that I used for the basic authentication. Right now, it was my admin user. So this is very difficult to debug. If you have an issue like something doesn't work, or this change shouldn't have been done, it's very difficult to find out who made the change. So that's why I wanted to recommend just use dedicated user if you can. All right. So we have this. It's great, right? It works. We have a webhook. We have callback. It all works great. But can we improve it? You have already seen this icon here. So I'm going to introduce Docker here. And the reason why I want to introduce it is there are multiple, but at least few of them. If you run in a Docker container, your microservice is kind of isolated. You know in which environment you run. You know which version of Debian or whatever base image you use. And if you have colleagues using Linux, Mac, or Windows, it all works for them the same. No matter which version of Node do they have, no matter which version of IDE they use to compile things. It's one container, you build it, and you run it. For DevOps, it's also great, because you can just deploy this container into Amazon, and it's just going to work. So we'll be just doing something like this. We're just going to put our microservice in a Docker container. And that's actually simpler than you might think. So we're going to use Alpine-based image, which is very small, I think like 10 megabytes in size. I'm going to use Node 6. That's not very important here. But the image is very small. It contains only the base stuff that you need. I'm going to use Workday source. It's just simple. And I'm going to add all my sources there. This expects that I have run the Node package manager, the npm install before. So I have all the dependencies pulled in. That can be part of your build process. This is just to show you that it's pretty simple to do. But once we have added all the sources, this container contains Node binary, your application, and that's it. Nothing else. Expose port 3000 to be able to connect to it. And I'm going to give it an entry point, a command to run. It's going to be Node, and it's going to use app.js as the thing to run. Well, this is just a definition. Now I need to build an image. That's pretty quick because I have cached all the layers. Give it a tag name so I can start it easily. And once it's built, it's all added. Container is done. Right now, I can run it, and I need to expose port 3000 from the container to the OS. And I'm going to provide it also environment file, which it's a file that I do not check in, but it's a file that contains all the environment variables that I need to have my service running. The application is listening on port 3000, and just for simpler reasons, I just made it that it's just going to show the JSON, as in one of the earlier examples. So this is application running in Docker, as you can see here. But it actually listens to events coming from JIRA. Nothing has changed in JIRA. You still talk to localhost 3000, but it runs in Docker. OK, that's great. But is this all we can do? Well, I had something extra here. And I don't know if you know the pricing in Salesforce, but they give you a couple of, I think, 100,000 API calls, which is quite a lot for free. But after that, you start paying. And in our world, we do not change the account owner every day. We change them maybe once in a quarter. So we do not need to actually do the API call every single time. We can cache that. We can use that information. We can cache that maybe for even a day. We save, even if it's a small amount, our volume of tickets is bigger. So it actually makes sense to store it. And it actually gives you a little bit of benefit of speed. So I'm going to use Redis to cache responses from Salesforce. And Redis, if you have never used it, it's a key value store, which allows you to very quickly store values associated with keys. It's something that's even supported by AWS as a service. It's written in C, I believe, and it's really fast. The reason why I'm not putting some sort of cache into my microservice, it's very simple. I want to keep the microservice stateless. I'm going to show you why later, but the whole state the microservice has is actually just this cache. Besides that, it's just a processor of events. So what I'm going to do now is I'm going to introduce Redis, and I'm going to use the domain name as a key, and the value will be the account owner. So whenever a request comes in from JIRA, I'm going to first check in Redis cache, do we have information about this domain? If not, we're going to call Salesforce. If we do have information, we save the call to Salesforce. We're just going to update JIRA issue. Docker Compose is used to do this. It's a simple way to spin up multiple services if you want. Here I'm just adding one service, which is the Redis service. It creates a virtual network around it, so these two containers see each other using host names, and it's pretty easy to build, rebuild, spin it up. So it requires this Docker Compose YAML file, which is pretty self-explanatory. I define two services here. One of them is my web service, which is actually just listening on port 3000, and it's using the Docker file that we have created before. And the second container that I have here is the Redis container, which just basically uses the Redis Alpine image and exposes the port 6379, which is the standard Redis port. This is just containers. Nothing actually changed in the microservice. So to actually make use of this, I'm going to use a library called Redis, surprisingly, to make some calls to this data store. So I'm going to create a Redis client, connect it to Redis port and Redis host, define the environment variables. And this is just a client. So you can see there's a JDBC client, kind of. You can make some calls like get key or set key. It's very simple. It's not very complicated. I've extracted the call to JIRA in a separate function because I'll be using it from 2 spots. But this function just updates JIRA issue with the data that we pass it to. So that's just the same code we have had. The only change here is instead of always making call to Salesforce to get the data, I'm going to first call Redis to find out, do you have a value for a key domain? And I'm going to provide a callback function. The callback function expects 2 parameters, and the second parameter is the cached value. The design of this Redis client is, if there is a value in the cache, it's going to be put into the cached owner name in my case. If there is nothing, it's going to set it to null. So null means there's nothing in the cache. We need to, with a cache miss, we need to go call Salesforce, basically have the same code with one small change, that once we get the data that we care about, we somehow want to store them. So that's happening actually on line 84. So here, before actually making the call to JIRA to update, we already know who the owner name is for this domain. So we're going to set this value. I don't know why they call the method setX, but that's the name. We're going to set this key, the domain, to be the owner. And in Redis, you can specify expiry time on each key. So there is eviction policy. You can say after 1 day, this key is no longer valid, so it's going to be expired. And then we're just going to call JIRA to update the issue. The more interesting part is the second part of the if branch, where we actually found something in the cache. So that's here. We actually found a record in cache. We don't need to do any call to Salesforce. We just update the issue. Let's try to build this and see if it works as expected. So Docker Compose builds both containers. The second one is just an image. First one is going to use Docker build to build that. And we're just going to start it up. As you can see, on the left side is a container name. So the first is Redis_1. It's a Redis container, and it's starting, and web_1 is starting as well. Web_1 is the one that my application is running in. I'm going to create an issue and see if it's cached. It shouldn't be cached because I have never done this before. So you can see it here. It actually sees the domain is Atlassian.com. The issue self-link is set here. There's a cache miss, so it's going to call Salesforce. It's going to store it afterwards in JIRA. More interesting is, if I now create issue with the same reporter again, it should really be cached because we already stored the value in Redis. And it is. It's much faster, as you can see. And it says found in cache. It just says the value on JIRA issue, and that's it. We didn't have to, we saved one call. It's not much, but it's something. And this is actually it. We have built a service which can actually be extended with Redis, with SQS, with whatever. So just, I would say, embrace the possibilities that they are there. There's so much more you can do now than you could probably do the same in JIRA. It's just going to be much more tricky. So I've shown you some of the stuff you can do. Something like using Docker, Redis. You can use Lambdas, SQS, Kinesis, all kinds of things. There is also a great thing and not so great thing, because you're running a service. So you need to make sure it still stays up. You want to make sure it's monitored. So you want to have some sort of log aggregation. We use Splunk at Atlassian. You can use Elasticsearch, Kibana, Logstash, whatever. Just make sure that you monitor your service and you monitor the logs. And monitoring itself, you can use StatsD, we use Datadog, but there are different tools that you can see, like, is the service running at its limits? Do I need to have a bigger VM to run it? Or, if you're stateless, as I've shown, with a Redis container, all the state is just in the container. So we can just spin up more node processes. more containers running the same node job, just running on different EC2 instances, for example. Because the only state that is there, it's stored in the Redis cache. So what we used to do, we have a load balancer in front of it. So whenever a webhook comes in, the load balancer looks where it should go. There's no state, so it's just a worker. Once it's done, you can just scale horizontally very easily. So this is something that proved very, very good to us. And I would never go back to storing the state if I do not have to. And lastly, you can deploy and run anywhere. So if you want to run on DigitalOcean or Heroku or even like AWS or even a bare metal, doesn't matter, you can just do it. And you can use Bitbucket pipelines to deploy. There is basically no limitations onto this. Unfortunately, it's not all roses. There are some gotchas. So it's the standard way of networking. It requires you to have a direct connection between your microservice and the JIRA you wanted to talk to. So it works well if you're just designing a private marketplace add-on that you run yourself against your own instance. But if you want to have something that customers can use, you might need to go through VPC peering if you're in AWS, or you set up an IPsec VPN tunnel. It's a little bit more work. It's doable. I've seen it working. The other option is you distribute a Docker container, and your customers can actually just install the Docker container in their data center and run it on their own hardware. It's a possibility. Just need to package it differently. On the packaging, you might want to distribute the add-on in Marketplace, and Marketplace requires you to have either jar or Atlassian Connect JSON. You don't have any of these, so you might need to create a bootstrap add-on, a small P2 add-on that just is a jar, has some sort of add-on key that's available in Marketplace, and that's actually a good thing, because what you can do then is you can use this add-on to provision the users that you need to provision, or the access. Or if you need to have some sort of security thing set up, like permission schemes, you can just have a guide that goes and tells the end users or admins, like, oh, to actually do this, you need to open a permission scheme to allow this. So I think that's just something to consider. And last thing that I didn't talk too much about is the custom UI is always more work. I didn't have to use that. I have ideas how to do it. So I stored a lot of the values in custom fields, because that's something that works directly out of the box with JIRA. You can use iframe and just pull data to this iframe using P2 add-on. To do this, you need to have JWT or some sort of authenticated path to your microservice. You can definitely do that. It's just a little bit more clunky, and you need to have a little bit more work. But then, if you do this, you are very well set for Atlassian Connect. Other alternative will be using entity properties, which are available in server, and I think they're a little bit less used in server than in cloud, but entity properties allow anyone having access to issue objects, store arbitrary 64 kilobyte of any data that can actually be even indexed by JIRA. And there is no built-in display support for that, but you can use that to store things that you want to store somewhere, but you don't necessarily need to display. You can even attach entity properties to command objects or user objects. So that's a great way to have both of the worlds, like not having to build a UI, but having to store somewhere something in JIRA. After all of this, do you think it's worth it? I do think so. I do think that besides the additional things that I've shown you, like you can use all kinds of services, you can also have a lot of reuse in Atlassian Connect. You can even reuse it in other SaaS platforms like Zapier and things like that. You can have zero downtime upgrades, which is great if you want it. And we actually use it, so whenever we need to upgrade a service, we have another stack running. So if you need to roll back, we just flip in the load balancer the host names, and it just works. Everyone is on the latest version of your add-on, so you do not necessarily need to support the older versions because you are supporting the add-on. And the last thing is, you learn a lot. So the last thing that I want to tell you, pick the right tools, go build your add-on, microservice. Thank you.